Hi Year 7, welcome to your second weekly update. It was great to see 104 of you on our live question and answer on Friday. It was fantastic. Lots of good questions, and actually we really struggled to get through answering all your questions in that half an hour. So we're changing the timetable ever so slightly for you next week. The times remain the same. On Wednesday, do your online lesson as normal. On the Thursday lesson, do your online lesson number 2 as normal. So by the time you've finished those 2 lessons on the Wednesday and the Thursday, you've done the online lessons from the Oak National Academy. Then you've got your homework set on Thursday night. I'd like you to do, or your team, your teacher for Year 7 Science would like you to do your past paper question booklet, which will be attached to this Show My Homework post, and also have a go at the online quiz. Now that shouldn't take you, it should be about 20-25 minutes for the past paper questions, and the quiz should take you about 15 minutes. Once those are done, you will have had accessed all of the learning for that week. You will have been able to test yourself on what you've learned, and you should have a pretty good idea about things that you're still not sure of. That's where the live lesson on Friday, where we will be there to answer your questions as best we can on Teams. That's what we're going to do from 11:45 on Friday. So we'll continue with this hopefully every week for the rest of the year, doing an 11:45 till 12:45 sort of online lesson, but with basically questions, answering your questions for that 1 hour. Please look in your Microsoft Teams and install that on any device that you prefer to use, and log in with your Show My Homework and stroke school login with your email and that password that you normally use. And look for the team that's called Science Year 7 Winton and Glenmore. At 11:45 on Friday, go into that team, and you'll find at the bottom of the chat there, you'll find a little button that says join. There's a meeting taking place. Click the join button and you'll be there. So in our Friday lesson, we managed to cover force diagrams and why we have them, how they work, why we use them. We also covered estimating population size using quadrats, and we used past paper questions to help work that out with a few examples in addition to that. So please do turn up on next Friday and each Friday after. Now, a little bit of help, some questions that have come through, which I want to see if I can address with you now. Relate to these 3 areas. So if we look at biology first, we've got questions about physical adaptations of living things versus behavioural adaptations. So really to try and clarify the difference between the two, if you look at an organism and you can see features that are physical characteristics that are helping it to survive. For example, I love hoverflies. They hover in the air, hence why they're called a hoverfly, but they look like wasps. They've got the same yellow and black markings, which makes them look really dangerous. But if they're not buzzing around flying like a wasp and they're just hovering in front of you, they're a hoverfly. Brilliant physical adaptation, because it means any predator will try and avoid eating the hoverfly because it looks like a wasp and it might do them some serious damage. Other physical adaptations, bears and loads of other animals really blend in well to their environment, and we call that camouflage. It can either help them to sneak up on their prey so they don't get spotted on their way up to the hunt, onto the kill, or it might stop them being prey so they can blend into their environment and stop any predators around being able to see them quite as easily. Those are physical characteristics of some animals, and we call them physical adaptations because we can see them. Now, behavioural adaptations are slightly different because these adaptations are ways that an organism actually behaves, so things that they choose to do. So, for example, bears we were talking about just now, they hibernate during the winter. They essentially go to sleep for long periods of time to save energy. Now that is a behaviour. It's not a physical thing that they have as part of their body. It's something they choose to do, and it comes as an instinct. It's a way they behave. Ants I love ants because they eat all the little aphids and flies on my roses in my garden, and I love ants. And the way they work so well together is they live in a big colony, they all have their own little job to do, and actually as they're walking around and they find some food, they leave a hormone trail behind them, so all the other ants can then follow the hormone scent all the way up to where the food is. It's absolutely brilliant. And that's a behavioural adaptation because it's something they do rather than something that they have as part of their body. So I hope that makes a little bit of sense. The second of the three things I might be able to help with are types of characteristics that we have. We have some characteristics that are caused by the environment. So it's completely dependent on where that organism lives and what sort of input it has during its life that will cause environmental characteristics. Now things like that might include if you fall over and cut yourself and you get a graze, you get a scar and the scar stays with you. That's caused by the environment because it doesn't involve your genes. Your parents can't pass on a scar through the genes, through the genetic information that's passed on during reproduction. It's just the environment. Another thing that would be purely down to the environment would be which language you speak or which languages you speak. Because if you were brought up in a certain country and you'd never left a particular village or a particular country, you'd only been exposed to one language, you would end up speaking that language. It's purely down to the environment. You can't pass on to children the language that they speak. You have to teach it, and that happens purely through environmental input. Same thing goes for being able to learn a musical instrument or be able to learn how to play a particular sport. And those are all environmental characteristics. In other words, they don't involve any genetic information being passed on from parents. Now, other characteristics would be genetic characteristics, and those are passed down from parents to their offspring. And those would include your natural hair colour, your natural eye colour, and there's a whole host of other things as well, which just purely down to the genetics. There are other characteristics which are actually a combination of the two, and those would include your height. So you have about 10 genes for height, but if you had, say, two twins and they were born and then they grew up in two different areas and one of those twins was malnourished, so they didn't get enough food while they were growing up, then they wouldn't grow to the same height as their genetically identical other twin. And that would be because there are some environmental factors that are influencing the height of that person. So you have environmental characteristics, genetic characteristics, but some caused by both. Weight is another one that's caused by a bit about your genetics. Some people burn food off faster, that's called a faster metabolism. And depending on what diet you have and what exercise you do regularly, that will also determine how much weight you put on or what your weight is from a day-to-day basis. Now, the last section is physics, and I had a question about this on Hooke's law, so we'll have a look at that next. So what is Hooke's law? In 1660, a Scottish scientist called Robert Hooke did lots of experiments on elastic objects. And we've got an elastic band, we've got a ruler here, could also have a spring. And they're all elastic, and the definition of an elastic object is something that you can apply a force to and it will change its shape, or it will extend, and then it will return back to its original shape afterwards, just like a spring would as well. So this law applies to anything that behaves in an elastic way. And what he did after lots of experiments was he found out that if you apply a force to an elastic object, the force that you apply will cause it to change shape. So I could hang something on this elastic band and it would stretch a certain amount. The amount of extension, how much this would stretch, would depend on how much force I applied. So if I put 1 Newton on and it did that, and then I put 2 Newtons on, it might do double. In fact, it would, because of Hooke's law. If I then put 4 Newtons on, it would be double that as well. So every unit of force applied to it will cause a proportional increase in the extension of the elastic object. So I've got a little definition here. Hooke's law basically means that the extension of an elastic object is proportional to the force applied to it. And it isn't really any more complicated than that, unless you start to look at what the graphs might look like. So you can draw a little graph. We can add weights onto a spring or add weights onto an elastic band like I was showing you just there. And we can measure how many newtons of force the weight would be applied to the elastic band. And as the force increases in equal amounts, we would find a straight line graph on how much the elastic band extends. So we would call this extension, whether we measure that in millimeters or centimeters or meters. What it means is we always get a dead straight line, and that shows proportionality between force and extension. That's the basics of it. For something a little bit more complicated, then we can introduce the idea of a spring constant. A spring constant. Now, this is a value that we give to an elastic object. Now, we've all seen different elastic bands of different shapes and sizes, and we know that some elastic bands stretch really easily, and some elastic bands take a lot more force to stretch. Now, spring constant really describes how hard it is to stretch a material. So it's a kind of an indicator of how strong a spring is. A high spring constant means a very, very strong spring. And we can actually calculate the spring constant from a graph like this. And there's a simple equation that we can use, which is the spring constant is calculated by entering the force in newtons into your calculator and then press divide, and divide that amount of force, wherever it is on your graph here, by whatever the extension is. So our force might be this, and we'd find out what the extension was, and we'd divide it by whatever that number is. So force divided by extension, which would have to be converted to meters, would give you a number which tells you the spring constant. And the spring constant is measured in units of newtons per meter. So it's literally taking the same unit as the calculation that we're using to measure it and to calculate it. So I hope that makes a little bit more sense. If you've got any questions about that, or any of the past questions that you've had in science over the previous weeks, can you please ask us on Friday in our live question and answer session. I hope this has helped to some extent with some of the areas that you're struggling with, and I look forward to seeing you on Friday. Okay.